This slide you already have in your notes. This was the very last one that we discussed, I believe, on Friday, that dealt with neutralization reactions. Just a little bit of a review for us. What type of a reaction is a neutralization reaction? A double replacement reaction, in which what's happening is actually the positive ions are being flopped. So the sodium is being flopped and replacing the hydrogen and vice versa. So we get NaCl and HOH, which is actually water. So the products of a neutralization reaction are a salt and water. We talked about this one here, okay? We talked about this one here, how this was a diprotic acid, meaning there were two hydrogens, okay? And I told you, notice that when I have two hydrogens here, I need to have two hydroxides. Now let me ask you a quick question, just a little further review. If I needed two hydroxides, why didn't I do this? Who can tell me why that is an incorrect way to write that? The K only has one what? The K has one what? This is all the way back to bonding. Probably first 9 weeks. Okay. It is an ion. Okay. The K has one positive charge, meaning that it has done what? It has lost one electron. The hydroxide on your ion sheet will be a -1 charge, meaning that it has gained one electron. So if I would write it like this, the charge for the hydroxide here would be -2, and that would be -1. So I need to take care of it by balancing, okay, by balancing, not by just adding a second hydroxide. That's going to be important. We're going to need to have balanced chemical equations when we talk about titrations, which is here. A titration. Now, that very first chemical equation that I just showed you is the one we have right here. And as you noticed, when we had the balanced chemical equation, the ratio of the coefficients, 1, 1, 1, 1. Everything has 1 when this is balanced. So we can say that 1 mole of hydrochloric acid plus 1 mole of sodium hydroxide will yield 1 mole of sodium chloride and 1 mole of water. We discussed that when we said, what does a balanced chemical equation actually tell us? So if you look, my acid to base ratio is 1 mole to 1 mole. Now here was the second one. As you can tell, is my ratio 1 mole to 1 mole for this one? Is my ratio 1 mole to 1 mole for this particular equation? No. And the reason is that I have that diprotic acid. So 1 mole of sulfuric acid will react with 2 moles of sodium hydroxide to give 1 mole of sodium sulfate and 2 moles of water. So 2 moles of the base is required to neutralize 1 mole of the acid. How do you know that? You can read it by the coefficients in the balanced chemical equation. Now, just another reminder, you probably want to go way back and review your acid rules and naming. Remember, we had 3 different acid rules, and it dealt with the endings, whether it was an IDE, whether it was an ITE, whether it was an ATE. Probably going to want to review those because you will be naming some acids here in the next few days. So if you need to brush up on your acid nomenclature, the 3 rules, find those. The amount of acid or of base in a solution is determined by carrying out the neutralization reaction. And in order to do a neutralization reaction, we need to have the proper or an adequate acid-base indicator. Now, you folks dealt with the lab recently, pH and color indicators. pH and color indicators, in which you saw you made different serial dilutions, and once you made those serial dilutions, you added indicators and saw that the indicators actually changed the color of the solution. Now, if you look at pH paper, trying to find it up here. I don't remember where. There it is. Good guess. Okay. If you would look at pH paper, they give you a color chart that corresponds with different strengths of acids and bases, right? And we talked about the pH chart. Well, what this pH paper is it is paper that is dipped in universal indicator. So as scientists, we know what color universal indicator changes when it's in a certain strength of an acid. Okay? Kind of goes with, you looking at that right there? Roy G. Biv, doesn't it? Okay? We know old Roy, don't we? What is it? What's Roy G. Biv? Rainbow. Okay? The rainbow. So, we know the Roy G. Biv, and it's telling me right here that if I have a pH of 0, it is red. If I have a pH of 1, it is sort of in between reddish and orange. So that indicator tells us the strength of that particular solution. Now, when we have a neutralization solution, okay, when something is neutral, what is the pH? 7, right? The pH is 7 when something is neutral. So, it would be really, really nice if we could find a color indicator that changed right around 7, wouldn't it? Well, the one I have up there listed on the smartboard, phenolphthalein is how you pronounce it. You actually tested. This was the second one that you tested. Okay? Phenolphthalein, okay? Right here is phenolphthalein when it's in contact with an acid. Okay? When it's in contact with an acid, it is a clear color. Now, how has it changed as I go from picture to picture? Okay? It's a kind of a fluorescent pink, right? Okay? Yeah. Phenolphthalein? Yeah, it's pretty important. I'm not going to say you need to know how to spell it. Okay? Right. Phenolphthalein, it's a tougher one to spell. However, I'm not going to count it wrong if you spell it wrong, but you should recognize phenolphthalein and you should know. Okay? You should know the following, that when in phenolphthalein is clear, it is in an acid. Okay? When phenolphthalein is pink, and even this one, see how that's a lighter pinkish color on the middle one? Okay? That is probably what we'll see here, probably called somewhere near the end point, meaning that's neutralized. So, if phenolphthalein is pink, okay, the pH is 7 or above. So, does it actually tell you if phenolphthalein is pink that it's a base? No, because it could also be 7. It could be neutral. So phenolphthalein will say, okay, acid or not an acid. Now, that helps us with the whole idea of titrations. And I will give you a second to write this down here. Okay, the steps for performing a titration in which we are neutralizing a solution is, number one, you take a measured amount of an acid of unknown concentration and add it to a flask. Okay? It doesn't have to be a flask. Doesn't necessarily have to be the acid. You could add the base. So the base could be the unknown. All right? So you take the unknown amount of acid or base. In this situation, we're going to use acid. And to it, you add an appropriate indicator. Phenolphthalein is the one that I love to use. Then you take a measured amount of a base of known concentration. And you simply add that base until we have what we call an endpoint where neutralization has occurred. All right? So, we take a measured amount of a known concentration to determine a measured amount of an unknown concentration. Now, I'm going to show you real quick this endpoint here. Strange feeling that we're going to learn here. This is not that intimidating, Kyle. This is how we calculate titration problems in which we are using the molarity of a solution. So, MAVA times MRB is equal to MB, VB, MRA. Now, what does each thing mean, and do the color codes mean something? Yes, they do. Yes, they do. I have color coded these to try to help you. MA. MA is the molarity of the acid. What do you think VA is? Volume of the acid. So molarity of the acid times the volume of the acid times MRB. That's the one that probably you don't know. Molar ratio of the base. So MRB, molar ratio of the base. So the volume, the mass of the acid times the volume of the acid times the molar ratio of the base is equal to the molarity of the base, the volume of the base, the molar ratio of the acid. So, when we're dealing with molarities, we need the molar ratio. Where are you going to be able to find this molar ratio at? Awesome. The coefficients of your balanced equation. So the molar ratios come from the coefficients of your balanced equations. So, let's jump right in. Go ahead and copy this down. This is our first titration problem that we will be working. A 25 milliliter solution of sulfuric acid is neutralized by 18 milliliters of a 1.0 sodium hydroxide solution using phenolphthalein as an indicator. What is the concentration of the H2SO4 solution? Well, the very first thing we need is I look up here and I say, okay, I'm dealing with molarity, capital N, so I need the balanced chemical equation for this reaction. Now, this happens to be one that we have been using, so I believe that when I come here and click next, it's going to give me, there we go. There is our balanced chemical equation for sulfuric acid reacting with sodium hydroxide. Now that I have that, I have all the material that I need to calculate the concentration of the acid. MA, VA, MRB is equal to MB, VB, MRA is the equation that I just gave you. We just go through, how I do it is I just simply go through and fill in numbers for what I got. MA, what is the molarity of my acid? What is the molarity of my acid? Molarity of my acid is unknown. That is what I'm trying to figure out. So I'm going to leave that as MA. What is the volume of my acid? 25 what? Now, this is a good point as any, folks, to discuss this part. If I have consistent volumes, it doesn't matter what label it is. And what do I mean by that? I don't have to have liters. I don't have to have milliliters. I just have to be consistent. So if I have milliliters for the volume of my acid, what should the volume of my base be in? Milliliters. If I have something like drops, didn't I use drops when I showed you the demo? Can drops be consistent? Yeah. Yeah. So just so I'm consistent with my volume, I could have any label. It could be milliliters, it could be liters, it could be drops, it could be buckets. Just so I am consistent. Yeah, the one that I just gave you in red and blue is what this is. Now, here is the part that you don't know. MRB. I look at my balanced equation and I find the base. Which one is the base? NaOH. What is the coefficient with NaOH? 2. So my MRB is 2. That will be equal to my MB. What is my MB? What is my MB? 1.0 molar. What is my VB? 18 what? Are my volumes consistent? Yes. What is the molar ratio of my acid? 1. Here's my acid, right? Right here's my acid. What's the coefficient? 1. So as I go through, I can see this is MA times 50 is equal to 18 divided by 50 divided by 50. So MA is going to be 18 divided by 50. And the label is going to be molarity. So 18 divided by 50 is 0.36 molar. And what is that? The molarity of the acid. The molarity of the acid. That wasn't too tough, was it? Okay. That wasn't too tough. We're going to roll with one more here, folks. Okay. Whoops. Go ahead and copy this one down. Now, I wanted you to go ahead and do the balanced equation because I didn't include this. But while you're copying this down, I'm going to balance the equation. And I need to start with my acid and my base. So chromic acid, okay? Chromic acid chromate, because I see the IC, I know that chromate is CrO4 2 minus. So in order for that to balance out as an acid, I need H2CrO4. iron 3 hydroxide, FeOH3. I'm going to do my double replacement. So I'm going to get iron 3 chromate, which is Fe2, CrO4, 3, and water. Now that's a skeleton equation. That is not balanced. I need to come through and balance it. I can see that I need 3 chromates. I need 2 irons. When I do that, I can see that I have 3, 6. I think that should balance it. 6 hydrogens, 6 hydrogens. Three oxygens. Yeah, that's balanced, isn't it? All right. So now I go into my Ma, Va, MRB is equal to MB, VB, MRA. What is the molarity of my acid? 2.0 molar. What is the volume of my acid? 16 milliliters. What is the molar ratio of my base? What's the molar ratio of my base, folks? 2. Where'd you get that? Balanced equation, right here. What is the molarity of my base? I do not know my molarity of my base. What is the volume of my base? 50 ml. What is the molar ratio of my acid? 3. So, if I'm doing my math right, I take 64 and I divide it by 150, and my molarity of my base is equal to, I see 2 sig figs, 4.43. Point 4.3. Now, which is more concentrated, my acid or my base? My acid, right? So it should take less drops of the acid to neutralize that base, right? Is that the case? Yeah, well, not actually drops, milliliters. Okay.